Hello everyone, Krishna this side. So in this video, I'll be covering this LeetCode problem 3202. Find the maximum length of valid subsequence true. Okay. So problem statement is small. So let us try to read it and understand what it is trying to say. You're given an integer array nums and a positive integer k. Okay. Those are the inputs that are being given to us. A subsequence sub. Okay, of nums with length x is called valid if it satisfies whatever the subsequence that we pick it from this numbers array. Okay, subsequence is basically the array itself can be a subsequence, or even we can remove few of the array elements and we can create a subsequence. Okay, so it is not a like sub array. Subsequence is kind of like we can form a subsequence by picking any of the elements from the array and we can generate the answer. Okay, so once we get the subsequence, okay, so whatever the subsequence that we have, in that subsequence the zeroth index plus first index modulo k should be equals to first index plus second index modulo k. So yes, whatever the subsequence that we have picked from the given array, when we add the adjacent elements with modulo k, whatever the answer that we are getting, it should be actually equal. Okay, that is the simple condition they are saying it. So that is a valid subsequence they are saying. So we have to return the longest valid subsequence of these numbers. Okay, so yes, that is the ask. Let us try to see the first example. From this first example, this is the array input that has been given. K value is basically equals to 2. So when we create this subsequence, okay, when we pick this subsequence, the array itself can be a subsequence. Okay, so when we add this 1 and 2, the addition elements, subsequence of 0 plus subsequence of 1, modulo k, when we do that, basically 3 modulo 2 is basically 1. So 1 is the answer that we got. When we add this 5 something what we are getting it, modulo 2 basically answer again we get 1. So 3 plus 4, 7 modulo 2, answer again 1. 4 plus 5, again the answer is basically 1. When we perform this subsequence of that particular index plus subsequence of next index modulo k, when we do that, we are getting it 1 as an answer for all these values. Okay, picking the adjacent pairs. So this way, this is a completely valid subsequence. So its length is basically 5. So that is something what we have to print into the output. Okay, and the length should be the longest valid subsequence length. Okay, so considering all these things, let us see in the constraints as well what are the values that are being given to us. So here in the constraint, the nums length is basically 10 to the power of 3 and k value is also 10 to the power of 3. So when we try to generate the answer also, like in n square, n cross n, it is basically 10 to the power of 6, or even n cross k, the answer is 10 to the power of 6. So it is completely valid to write the code in n square. Okay, we do not have any constraint right over there. So the expected complexity is valid if we try to write the code in n square. Okay, so considering all these facts, now let us look on this particular screen. Let us say that this is the array that has been given. Okay, this is the array that has been given and k value is basically equals to 4. Okay, so I may get different pairs right now. Okay, so when we try to add 1 plus 3, when we do this 1 plus 3, 4 is what we are getting it, and fourth module of k value is basically 4. The answer is basically 0. 0 is the reminder that we get it. Okay, now next is like 1 plus 4, we can do it by just simply not considering this 3. Okay, 1 plus 4, if we do 5 is something what we are getting it. When we do this, 1 is the answer that we are getting it. Again, like if I try to do this like 3 and 4, 3 plus 4, the answer is 7. Modulo 4 is basically 3. So all these values are different, they are not same. Okay, so I cannot simply pick 1 3 4, because this 1 3 is basically given me 1 3 giving me 0 as an answer when we do this addition modulo. Okay, 3 4 individually giving us 3 as a reminder. Okay, 3 as a reminder. 1 4 is also giving us a different reminder, it is not constant. Okay, so this is like 1 is the answer that we are getting it. Okay, so here we are having different possibilities considering different pairs. Okay, there could be chance that in future some of the pairs may give same answer, but right now here if we see, we are getting different values. Okay, so these different reminders that we are looking at right now here, how long they go till from 0 till whatever this k value is there, k minus 1. Because when we divide from a with any number, okay, let us suppose 4, when we try to divide any number with 4, the maximum reminder that we can get is 3. Okay, 3 is the maximum reminder that we can get it. So from 0 till 3, we are getting all the different reminders when we try to pick any pairs and try to modulo with this k value. Okay, because k value is 4, so we are getting 0, 1, 2, 3. These different reminders possibly we can get it. Okay, so yes, for each and every single pair we may have different values. Those are ranging from 0 to 3. Okay, those are ranging from 0 to 3. So yes, we can maintain a state. We can maintain a state because there is a chance. Now here, see, if I pick this 1 and 3, if I pick this 1 and 3, the answer we are getting is like here 0 is the answer that we are getting it. When we add and modulo of k, 0 is the answer that we are getting it. And now when we skip this 4 and when we pick 5, when we pick 5, 3 plus 5, now 1 plus 3 is basically 0 is the answer we are getting it. 3 plus 5 is what? It is basically 8. 8 modulo 4 is again 0. So yes, this is a valid pair. So now for this particular 1, 3, 5, we are getting 0 as an answer by picking the adjacent values. Okay, so this way, like, we have different possibilities. Okay, different possibilities, so we have to consider them. We have to consider them, all these different possibilities that we are getting it. What we will do, simply we will maintain their states. For one, we will be having four different states. Those are like 0 could be a reminder that we can get it by pairing with any number. 1 can be a possible answer, 2 can be a possible answer, 3 can be a possible answer. For 3 also same. When I try to add this 3 with 1, I can get it either 0, 1, 2 or 3. Any of these values can be, we can get it. So what we will do is initially this 1 will get filled with 1, or entire these states will get filled with 1, because that number itself individually can be an answer. Okay, so what we will do, we have next is 4. For 4 also, like, we will be getting different states like 0, 1, 2, 3 when we try to pair it with previous numbers. Okay, for 5, 6, 7, so we will be getting different pairs, reminders. So yes, the first step that we will do is, let me just clean this up, and I'll create an array, dp array. Okay, we can say it as a dp array. So yes, probably because this is the problem from the dynamic programming, we are maintaining the state. So let me bring this up. So this is the step, particularly this is how the array may look like. Initially all the values are filled with 1, because that individual element can be an answer. Okay, so initially these values are basically filled with 1. So first, this whatever the 1 is there, that can be an individual answer. Okay, so 1 can be an answer. So now what we will do is, we will start traversing from 3. We will start traversing from 3 because we need to create pairs right now. With 1 we cannot create pair individually, and what we will do is, from 3 we will try to go in a backward. Okay, so I can create here different pairs, right? I can try it out different possibilities. So now we will run a for loop. Initially the for loop start from 1. So basically I is basically equals to 1 to whatever the length of this one. So length, till that we will run this for loop, I equals to 1 to length. Okay, next for loop will start from this particular I minus 1. Okay, and it should be greater than or equals to 0 and j minus minus. That is the next for loop that we will run. Okay, two for loops we can run it easily, and we can write down the code as well, because we are not sure that which pair basically gives us best answers. Okay, which pairs basically uses best answers. So we will try to generate all different pairs possibilities, and we will get the answers, and we are maintaining their states as well. You will get this idea, like what these states are basically doing right over here and all. Okay, okay, now this I is basically starting from first index, so I is currently pointing at these 3. Okay, we are trying to generate all the possible pairs, okay, here in this particular case, because that way only we'll get to know what is the exact reminder that we are getting it, and by following those reminders, can we get the longest subsequence who's having the same kind of reminders. Okay, that is the thinking that we are getting it right now at this particular point in time. So yes, we actually created the first for loop starting from the first index, that is like 3. I is currently pointing at 3, and the second for loop running from the previous index, and it will go all the way to the 0. So previous index is actually the 0th index. So yes, we will try to see if 1 plus 3, 1 plus 3 modulo k, if we try to do whatever the reminder that we are getting it here, reminder is 0. Okay, so reminder we got it 0. So what we will do, we will go and check in this 0th place for this particular j index. Currently j is pointing at 1. Okay, so we will go on that 0th index, what is the previous value that we got it. So previously it was 1. Previously it was 1. What we will do, we will update the dp state. So dp of this particular I, which is basically 3, and this k, what we will do, whatever the previous state that we were having, previous state was dp of this J and K. Okay, J and K. Sorry, it is J and this K, it is not K actually, it is actually this reminder. Okay, whatever the reminder that we are getting it is not K. So dp of this I and this reminder. Okay, what we are doing, we are previously whatever the previous state that we got it. Okay, so that state plus 1. Okay, that is something what we will update right over here. But there are chances going ahead, this dp of this J reminder, whatever the value that we are getting it could be small comparing with other different pairs. What we will do, we will try to maintain here maximum between dp of J plus remind J of J reminder plus 1, or this whatever the dp of I and reminder. Okay, that is something what we will keep on maintaining it. This way what happens is this dp state will keep on getting updated. So now here, since we are creating this pairs, so in this particular place dp is place, so this is the dp array that we are having, right? So in this place now this value get updated with 2, because whatever the previous value was 1, 1 plus 1 is basically 2. That means we can create this 1 and 3 as a pair. Okay, so answer we are getting is 0, because when we try to add this 1 plus 3 modulo k, the answer that we are getting is 0. So at 0th index, because we may get 0, 1, 2, 3 these reminders. Okay, so whatever the previous states reminder that we got it. Okay, whatever the values, these values that we have, that means like those many pairs we got it so far till 1. So at 1 all those values can be a possible pair, that particular 1 itself can be a possible answer. So 1 plus this current state, that is 2. So far the answer that we got was 2. Okay, that is something what we have updated, because the reminder that we got here is 0. Okay, so simple thing that we have done so far. Now we cannot go further, this for loop is done. So this dp state got updated. That means like for the 0 reminder we can create this pair 1 and 3. 1 and 3 we can create this pair 1 3. This pair is possible pair, its answer is basically 0. Okay, and in the 3 we have already updated its state, because that is the longest length that we can get it so far. Now let us try to shift our I. Now for I equals to 3, that is I equals to 1, that is been done. So this value got updated to, previous value was 1, this new value got updated to 2. Okay, that is the change that we got it so far. Now this I is basically pointing at this particular one, 4. Okay, now we will again check. Okay, same thing we are doing it, whether 3 and 4 can be a possible pair which can gives us the best answer. Okay, so 3 and 4, when we add it, 3 plus 4. Okay, that is the second for loop that we are running it, right? So J basically pointing at this particular index. So dp of this, whatever this values that we are doing it, calculation that we are doing it. So what we are doing it, 3 plus 4 modulo k, that is something what we are doing it right over here to get the reminder. 3 plus 4 modulo k, so it is like 3 is the answer that we can get it. So we will go and check what is the previous value at third index. It was 1, it was 1. Okay, so same thing we will update. So whatever the previous state value, we will simply compare. This is the same single statement that we are running it right over here. So it was 1, currently it is 1. So this pair can be a possible pair 3 and 4, which is giving us the reminder as 3. So here the answer got updated to 2. Okay, simply we will update from 1 to 2. Okay, this is the modification that we have done. Now with 3 we are done. With J value, now we'll go at this 0th index. So J value we will go at 0th index. So here it is 1, 1 plus 4, that is something what we will do. Okay, 1 plus 4, that is something what we will do. So 1 plus 4 modulo k, here the answer is 1. The answer is 1, correct? So we will go and check what is the value in that particular, for that particular reminder, in that this J equals to 0. J equals to 0, there what is the value that is available for reminder 1? Because there are chances, right? There are chances this one previously we were not having any pairs, so for that you are getting kind of confusion. Some of you guys may get confusing right over here, click why we are doing it. But going ahead you will get this idea, okay, this is why we are doing it. So whatever the previous answer that we have, that value plus this one, because this could be a possible pair, right? 1 and 4, which is having reminder as 1, which is having reminder as 1. Okay, so going ahead 1, 4, and we may get answer like, let us suppose going ahead something 9 is something what we let us suppose 1 is the reminder that we are looking at, right? So what could be a possible answer? 5, let us suppose 5 is the pair that we got it. So when we add this 4 plus 5, the answer is 9. When we do this modulo, the answer is 1. Okay, the answer is 1. That means these pairs, from these pairs we got answer as 1. These pairs also giving us the answer as 1. So if 5 is something what we are having, we will simply check what was the previous value at this fourth index, what was the previous value at this fourth index. So that we already updated. Now this pairs basically whatever, what is the answer here, it is 2. If we look into the DP array, it is 2. So in the 5, what we will do, whatever the answer that we have at this particular fourth index, okay, at this particular 4, that plus this new pair, okay, that is the longest length that we can get it. So that is something what we are doing it. So it is simply a LCS kind of problem, longest common subsequence. There also we do same kind of strategy we will apply. So if you have solved multiple similar kind of patterns questions from the DPs, you can easily solve this one. Okay, so now for 4 we are done. So two states got updated. It was like 1 is the reminder that we are getting it with 1. 4 plus 1, when we do 1 is the reminder that we are getting it. So its state got updated. Now for 4 plus 3, that is 7. 7 modulo 2 is basically 1. Sorry, this was basically giving us one answer. Yes, that is also we have updated here. Okay, now once this is done, we are actually moving this I value. Now I basically points here, I is basically here. So again we will check with 4 5 pairs. 4 plus 5 is 9. 9 modulo 4 is basically 1. Okay, 1 is the answer that we are getting. We will go in this fourth, check what is the value at reminder 1, it was 2. That means there was a pair, previous pair, and we already saw that 1 and 4 was the pair which was giving us reminder as 1. So the length was something we are already updated. Now 5 can be another pair in that one. Okay, 5 can be answer in that one. Okay, 1 4 5, this can be a valid sequence. Okay, so whatever the previous value that we have, it was 2, so we will simply update right over here. So 2 plus 1 is 3. 2 plus 1 is 3. 3 is something what we have updated right over here, because that is the longest length that we can get it. Now 5 and 4 we are done. 5 and 3 is something what we will do. J value got decremented. 5 and 3, 5 and 3 gives us the same formula. Is simple. This is the operation that we are running it right over here. 5 plus 3 is basically 8, because that is the operation that we are doing it, right? We are adding them, we are modulo with this k value. Here it is basically giving us 0 answer. Okay, at 0 plus 3, there was already a pair, right? It was like following 1 3, we already got 0 as an answer. So that's why we already updated its state. Okay, so 2 plus this one. Okay, because again this is another pair, right? So whatever the previous answer that we have, that plus 1, that is something what we are doing it, right? So it is basically get updated with 3. So now this 0 state also got updated with 3. Okay, with 3 we are done. Now with this 5 and 1 we will check. 5 and 1 we check. So the answer is basically 6. 5 and 1 is basically 6. 6 modulo 4, when we do, the value that we get is 2. So in that second index of this one, what is the answer? It was 1. So this is new pair. Okay, this is new pair. So far we got this pairs, right? 1 3 5, 1 4 5 with this 5, and then it is like 1 and 5, because its value is 2. So what was the previous state? It is basically 1 in this DP array. It is basically 1. So 1 plus new 1 is something what we will add, so it is 2. So that is another pair that we can get it. Okay, this way we are updating these values. I guess this should be clear now. So for 5 we are done. Now for 6 we will do. So again we will keep on checking this. 6 plus 5, that is 11. 11 modulo 4 is basically equals to 3. So we will go and check what is the value at this 5, because that is something what we are trying to update right over here. So at this 5, the third index, if we notice, because that was the reminder that we are getting it, right? So previously the answer was 1. The answer was 1. So we will simply consider that 1 plus this one, because 5 and 6 is new pair that we are forming right over here. So the total length that we are getting it longest subsequence for 5 and 6 pair is basically 2. So we will simply update this as 2. This will get updated with 2. Okay, I think that should be clear. Now 4 and 6 is something what we will try check. Okay, 4 and 6 is something what we will check. So 4 and 6. When we add these values, 10 is the answer that we get it. 10 modulo 4 is basically 2. So we will go and check what was the value for this 2 reminder when we are getting it previously. Are we having any pairs so far that we got it at this fourth index, which gives us reminder as 2? So there was no pair so far. So answer was 1 previously. So 1 plus 1 is 2. So in the sixth, we will update this as 2. Okay, because previously it was only 1. So this is new pair. Again, this is like 5 6 was new pair, 4 6 was new pair. That is something what it says, and its length is going to be 2. Correct, that's what we are updating this from this DP states. Okay, now 4 6 we are done. 4 6 3 is something what we will do, because that's the second j for j loop that we are running it, right? From I minus 1 to till 0th index we are going it, and j minus minus that we are doing it. So j basically points at this first index that is having value 3. 3 plus 6 is something what we will do. It is 9. 9 modulo 4 when we try to do, it is basically gives us 1 as an answer. So we go and check what is the value at this one reminder. It was 1. So again this value gets updated to 2. Okay, because this 6 and 3 is new complete pair. We were not having any previous pairs which were having reminders as 1. Okay, with 3 I'm talking about. So that is also done. Now 6 and 1 we will try to do. 6 and 1 is basically 7. 7 modulo 4 is basically 2. Sorry, it is basically 3. So at third index we check, the answer was 1. So again this will also what was the maximum answer so far we got? It was 2. So we will keep that as it is, because that is the formula that we have. Max between current reminder plus 1. Okay, whatever that current index or whatever the value that is already available so far by exploring it, that is something what we will keep maintaining right over there. So 2 is the same answer that we will maintain right over here. Okay, this way we will keep on forming these pairs, and there was at a point, particularly point, when we will get the maximum length. Okay, by following this particular steps. Okay, just let me take quick pause because it is hitting. Okay, let's quickly wind this up. So till 6 we are already done. Now for the 7, 8, 9, we will try to see what are different values that we can get it. Now the first pair that we can try is like with 7. It is like 6. 7 plus 6 is basically it is 13. 13 modulo 4 is basically 1. 1 is the answer that we are getting it. So we will go and check for this 6. What is the previous value that we got it? It was 2. Because having this reminder as 1, having this reminder as 1, with 6 we already have one pair. Okay, that is something what it basically says. We are just doing that operation only, right? So when we previously added this 6 with particularly 3, right? It was like 3 and 6. When we added them, the answer was 9. 9 modulo 4 is basically 1. So again, when we consider the 7 right over here, 7 is something what we are considering right over here. The 7 plus 6 is basically 13. 13 modulo 4 is basically again 1. Okay. So this way, what we are getting it, like this is the entire new pair that we can have it having length 3. So previously the answer was 2 at this particular index, having reminder 1 for this 6. So now for 7 the answer will be getting increased. It was 2. Previously it was 2. So 2 plus 1 is basically 3. 3 is the answer new. That is something what we are getting it, because this 7 is something what we are adding it into that previously whatever the list that we got it. The list was like 3 and 6. That was the pair that we got it right previously, having this answer as 2. So now 7 is something what we are pushing it. So 1 is something what we are adding it in that one. Okay, so that is the whole idea. Now we are done with 6. We will check 6 and 5. Sorry, 7 and 5. 7 and 5 is basically 12. 12 modulo what is this 4 is basically 0. We go and check what is the answer for this 0th index. That means like 0 reminder. For this 0 reminder, what was the answer in this fifth particularly fifth number? Okay, whatever this fifth value that we have, 5 value that we have in this particular sequence, what was the answer at 0th index? It was 3. It was 3. How? We already checked like 1, 3, 5. These were the pairs which gives the answer as 0 by considering them as same values. Okay, now 7 also giving us the same, because when we try to do this operation, same operation, 5 plus 7 divided by modulo 4, the answer is actually 1. So far at 5th index the 3 was the answer. Now we will simply add 1, because 7 is something what we are considering in that particular sequence. So this answer is 4. So we will update this state. So it is like 4. It is 4. We got up, we updated this DP array as in 4. Okay, whatever the maximum answer that we are getting it, that is something what we will replace at that particular DP state. Okay, now with 5 we are done. With 4 we will check. 7 plus 4 is basically 11. 11 is something what we're getting it. 11 modulo 4 is basically again here 3. So at third index the answer was previously 2 for this 4, because there was two pairs that we got it previously, 4 1 4 and this 7. This new pair something what we are getting it. So we will update this state as 3. Okay, here we will update this state. Previously it was 2. 2 plus 1 is basically 3. Okay, that is something what we are done. Now with 4 we are done. We will try to see with 3. 7 plus 3 is basically 10. 10 modulo 4 is basically 10 modulo 4. What is the answer that we get it? So it is basically 2. Okay, 2 is the answer that we are getting it. So 2 at second, what was the value? It was 1. Okay, it was 1. Let me clean this, all the mess that I am creating right over here. So here the value was 1. Here it was 1. And here it was 3. Just clean this. Okay, let me clean all this. Okay, it was 2, right? Yes. This is how so far it was looking. So when we add this 7 plus 3, it was 10. 10 modulo 2 is 2. 10 modulo 4 is basically 2. So 2 is something what we are getting it. We will go in the third, check what is the value. It was 1. Okay, it was 1. 1 plus 1, because this is new pair that we are getting it. 3 and 7, which is giving us the reminder as 2. Previously, till 3, we were not having any pair which was giving reminder as 2. Okay, that is something what it basically says. Now we simply update this state for 2. It is basically 2, because 3 and 7 is the new pair. That is something what we can consider having reminder as 2. Okay, 3 7 we are done. 3 1 is something 7 1 is something what we will check. 7 and 1, the answer is basically 8. 8 modulo 4 is basically 0. 0 is the answer that we are getting it. So at 0th index the value was 1, so this is completely new pair. So here the answer is basically, previously it was 1. 1 plus 1 is 2, because 1 and 7 is the new pair that we can have right over here. We can have right over here, but already the answer is 4. The previous answer was 4. There was this pair 1 3 5 7. This is the pair that we were having it, right? 1 3 5 7, which was basically giving the length as 4, and that is something what we already updated it. Already updated it. Is it really necessary to update now? Because here 1 and 2, this pair is basically having length 2. 1 and 7, this pair's length is basically 2. So is it really necessary to update it? Because previously value was 4, that is something what we have updated. No, we will not update it. That is something, the formula that we have generated right over here. Whatever the maximum value that is already available at that particular state, we will keep same as it is. We will not update based on this new state. Okay, so I think the idea is pretty much clear now for all of us. So let us try to compute for 8 9. So for 9, if we again try to see, 9 plus 7 is basically 16. Okay, and reminder is basically 0. So previously at 7, this 0 index, it was 4. So here it will get updated to 5. So from this particular array, the maximum answer that we can get is 5. That is the answer that we can get it. Okay, that is the longest pair length that we can get it. So we can simply traverse through this array and we can get this answer as 5, or else while getting this dp state, there itself we can maintain the answer. There itself we can maintain the answer. So how we can do it? Let us try to see on the screen, and let us try to write down the code as well. So you try to solve as many dp problems as possible. That way only you can easily get ideas in this dp problems. Okay, the first thing that we will do is we will create a dp state, and it is having length of, okay, sorry, I'm not saying. So let us try to get array elements. How many elements that we have? Nums dot length. Okay, here this array is basically n cross k. That is something what we have seen, the dp array completely table that I have formed. It is having at the top all the reminders that we can get it, 0 till k minus 1, and in the row wise all these nums, those are the values that we were having it, right? That is something what I have created. Let us try to fill this all the dp arrays dot fill. Okay, let me consider this in a stream, or else what I'll do is okay, let's try to use the stream API. Arrays dot stream dp. Okay, um, for each element that is available in this dp a, arrays dot fill a comma minus 1. Okay, I think this should be fine. The dp whatever the stream API that I'm using, it was arrays dot stream, or yes, I guess it is correct. I'm not sure. Let us try to see. If it is failing, then we will simply fill that one. Okay, we will start with 1. It is not basically minus 1, it should be 1. Okay, it should be getting filled with 1, because that individual element could be an answer. Okay, we'll start with 1, we'll go all the way till last index, and the next for loop is basically we'll run from j equals to I minus 1. J should be greater than equals to 0. J minus minus. Here we will check that. Let us try to get the reminder. Int reminder equals to nums of I plus this nums of j. That is something what we are doing, and modulo k. That is the ask. So we will check that. dp state is something what we are updating it. So dp of this basically I, whichever the element that we are at, and this reminder. Okay, that is something what we are updating it. We will update it with math that max between dp of I, this I and this reminder, or dp of this j reminder plus 1. Okay, whichever is the maximum, that is something what we will update it. And let us try to create here itself a max answer. max length or max length of subsequence, that should be fine. Max length will get updated with math.max between this dp of I reminder or max length. I think this should be fine now. I guess that's all we have to do right over here. So simply return this sorry, max length. Okay, and it should work fine. Let us try to see if it is working fine or not. Yes, it is getting accepted. Let us try to submit this code. So it should work fine, I guess. Yeah, it is getting accepted. Talking about the space complexity, this DP array is something what we have created it and we are trying to fill it. So the space is like n cross k. Okay, 10 to the power of 6 is what we will get it max. And we are running this two for loops. We are running it. So the first is like n. Again, the second is like at worst, like at the end, it is going to be again n. So n cross n is the answer that we are getting it. Okay. I hope you get the idea what we are actually doing in this particular problem, and try to solve as many DP problems as you can. That way only you will get these all the approaches. Okay, and it is actually a medium level problem if you think in DP terms. But if you have tried to solve all most of the DP problems, you will easily recognize the pattern. Okay, most of the problems are basically following the same patterns. Okay, so yes, that's all from this particular video. Thank you for watching this one. Bye bye.